Imagine lounging in pure comfort, watching Earthrise from your lunar mansion. You effortlessly leap 10 feet across the room in low gravity. You even discover beautiful, glowing alien life thriving in untouched craters. It feels like the perfect, prosperous future. But this paradise is a fragile trap. Soon, microscopic razor glass will shred your life support. A 45,000 mile per hour cosmic bullet will shatter your power grid. And a freezing 14-day night will slowly suffocate your glorious new world. Moon, silent graveyard of our greatest achievements. Cold, brutal, waiting. You landed in 1972. You planted a flag. You left. You never returned. But humanity is stubbornly ambitious. March 2026. The ignition plan is officially greenlit. A permanent South Pole base. What if you never leave? In the next 12 minutes, you will live the full 90-day experiment. You will experience low-gravity luxury. Watch that life die in your hands and learn exactly why humans still cannot stay. Okay, let's go. Your lander drops from orbit, slamming into the South Pole. A silent cloud of jagged dust explodes into the vacuum. You step onto the untouched surface. First, low-G jumps. At exactly 5.3 feet per second squared, you weigh virtually nothing. You feel invincible, for now. Let's face it, surviving out here burns cash faster than a rocket engine. Before we step inside your high-tech fortress, hit that subscribe button and drop a quick like. Done? Awesome. Welcome to day 1, the luxury phase. Under phase 3, your base is fully built. The power grid is a beast. A nuclear fission reactor hums quietly, backed by a reliable RTG. Inside, pure luxury. Earth-like pressure dials in perfectly at 14.7 pounds per square inch. Climate control maintains a steady 68 degrees Fahrenheit. You're lounging in short sleeves on a lethal rock. It's spiffy. You walk to the quartz window. Earthrise. A fragile blue marble suspended in absolute blackness. Exactly 238,900 miles away. You aren't isolated. You brought a companion. One low-G trained golden retriever. Watching a 65-pound dog realize he weighs just 11 pounds? Yeah, it's hilarious. He takes a running leap, floating 10 feet across the module. 1/6 gravity is an absolute playground. Exploration is thrilling. You unrack the Toyota JAXA lunar rover. This 33,000-pound machine crawls at 2.2 miles per hour, but it's heavily armored to survive 150 straight hours of crushing darkness. You launch autonomous drones executing massive 30-mile hops. Your Viper rover maps a staggering 560-mile range. Scoop raw dirt, feed it into 3D printers, and extrude extra modules directly from the ground. You're killing 2 birds with 1 stone. Day 12. History is radically rewritten. Deep inside a shadowed crater, temperatures hover near absolute zero. A drone picks up a thermal anomaly. You suit up, drive the rover into the pitch-black abyss, and flip on the 10,000 lumen high beams. You find them. Lunar glow hoppers. They measure 3 to 5 inches across. Flat, elliptical bodies. A thick, transparent skin perfectly blocks lethal cosmic radiation. They have 4 ultra-long legs. One compresses its limbs. It explosively launches itself. A staggering 100-foot leap in microgravity. They possess absolutely no eyes, but they emit a soft, pulsating, blue bioluminescent glow. Native alien life. You capture a live specimen. Bioscans are mind-blowing. They eat dormant ice bacteria and raw silicate minerals. The crazy part? Their metabolic byproduct is trace amounts of pure oxygen. Your heart pounds. You place them in a pressurized terrarium. Staring at this glowing life, the future feels possible. Day 31 arrives. The honeymoon phase abruptly evaporates. Daily survival kicks in. Your routine becomes a grueling chore. You mine ancient water ice from crater floors, zap it with electrical currents, and split water molecules into pure oxygen for breathing and liquid hydrogen for fuel. But the moon doesn't want you here. The dust invasion begins. Lunar dirt isn't soft beach sand. Without atmospheric wind to erode sharp edges, every microscopic particle is jagged, essentially 1-micron shattered glass. Static electricity from the solar wind makes it fiercely cling to every single surface. Ugh. The invasion is relentless. It seeps into airlocks, coats your suits, and physically grinds down synthetic rubber seals like coarse sandpaper. Then, the quiet sky attacks. Your first micrometeorite strike, the physical size of a grain of rice. But out here, there's no friction. Speed is the ultimate weapon. It impacts your primary solar array at exactly 45,000 miles per hour. To put it in perspective, that's 20 times faster than a high-powered sniper bullet. It hits delicate panels with the raw kinetic energy of a hand grenade. Ouch. Sparks fly silently. A massive web of shattered glass spreads across the array. The power grid destabilizes. You shouldn't be out here alone, but you're forced outside for a high-risk EVA repair. And then, absolute darkness. The first 14-day lunar night severely hits the South Pole. The sun vanishes. The surface temperature instantaneously plummets to a bone-shattering minus 330 degrees Fahrenheit. You wouldn't wish this cold on your worst enemy. Inside, violent thermal shock strains the base. The nuclear reactor flickers, a microscopic drop in megawatt output. Ambient temperature drops noticeably. You swap your short sleeves for a heavy thermal jacket. Early signs of biological failure show. Your dog becomes sluggish. No more playful leaps. He simply curls up near floor heating vents. You check the dark terrarium. The glow hoppers are dramatically slowing down. Frantic 100-foot leaps turn into painful crawls. Their soft blue glow dims to a fading flicker. Something fishy is going on, and no chemical adjustment can fix it. Day 61. Welcome to the absolute nightmare. In space, problems never just add up. They viciously multiply. A larger micrometeorite slips past early warning radar. It tears a jagged 1.2-inch gash straight through the secondary module. Alarms scream. Oxygen leaks into hard vacuum at supersonic speeds. Crap. You dive for the heavy steel bulkhead doors, locking pressure seals in the nick of time. But you're too late. Toxic, abrasive lunar dirt floods the interior. Microscopic glass coats your sterile living space like a dirty avalanche. The life support recycler ingests the dirt. Glass completely shreds internal filtration membranes. It violently clogs. The system crashes into critical emergency mode. Your food ration plummets to a miserable 1,200 calories. Your body enters rapid starvation mode. Water filtration fails. Every drop tastes sharply metallic. It's literally like sucking on rusty pennies. Day 75. The second 14-day lunar night hits. It swallows your battered base in pitch-black terror. This time, the dust-choked reactor struggles with extreme thermal drain. Heat output plummets. Internal temperature falls sharply. It hits 50 degrees, then 40, then a freezing 32 degrees Fahrenheit. You're shivering uncontrollably. You're forced to sleep zip-tight inside your bulky pressure suit, just to stave off fatal hypothermia. You desperately check the terrarium. The glowhoppers are dying, one by one. Without adequate ambient heat and trace oxygen, their transparent skin physically cracks like brittle ice. Their beautiful glow completely fades to a dead, ashen gray. Their ultra-long legs curl inward in a grotesque spasm. By the end of this freezing period, the alien colony is dead. You're left staring at dried shells and a bunch of bones rattling in a glass box. Goodbye, profound biological discovery. Your dog weakens badly. His breathing is shallow. His heart is failing under immense systemic strain. Day 82. The rover's critical battery bank shorts out. You have to fix it manually. You step outside into the absolute pitch-black, freezing night. You're starving, exhausted, and shivering. You make a clumsy, fatal mistake. You slip on a slick patch of glass-like regolith. You fall hard against the rover's undercarriage. A sharp piece of sheared titanium snags your suit. A near-fatal suit breach. You push the panic button. The extreme minus 330-degree cold hits your bare skin in exactly 90 seconds. Precious oxygen is sucked straight from your expanding lungs. Your peripheral vision goes black. You desperately slap an emergency patch of vacuum tape over the hissing tear. You drag your heavy, failing body into the airlock, hit repressurization, and collapse on cold deck plates, gasping for metallic-tasting air. You survived, but the base is entirely broken. Day 86. Final desperate repairs. You spend your last freezing hours executing frantic duct tape engineering. You violently cannibalize your own home just to survive. You manage to keep only the central core module barely alive. You've permanently lost one entire wing to vacuum exposure. It's now a frozen, depressurized tomb. Day 90. The comms console flashes brilliant green. A rescue lander finally descends from lunar orbit. Its massive engines kick up a chaotic storm of abrasive dust. You don't want to abandon your mission, but you're absolutely forced to leave. You strap yourself into the cramped ascent module. You survived 90 grueling days, but at what biological cost? Beside you, the dog is barely alive, heavily sedated. And the incredible glowhoppers, all dead, extinct, wiped off the face of the Earth. Well, off the face of the moon. A profound scientific discovery, permanently lost to space. As the lander violently lifts off, you look out the scratched quartz window at the ruined base. Moon, beautiful dead rock, goddess of the night, full of silence, your temporary tomb. People love confidently poking holes in the risks, boldly claiming modern technology will magically fix everything. But the brutal truth is radically different. We learned exactly why humans still cannot stay. The relentless, abrasive, microscopic glass dust, the invisible, hypersonic meteorites, the apocalyptic 14-day freezing nights. A permanent lunar colony might be possible for heavily armored future generations, but currently, it's simply too dangerous. If we truly want to build a second home for humanity, it makes far more sense to set up a base on Mars for now. At least there, a thin atmosphere and a 24-hour day-night cycle give us a real fighting chance. Sound like fun? Probably not. If you survive this grueling lunar nightmare, smash that subscribe button and leave a quick like. The universe has laws, but we're here to push them to the breaking point. I'm Rabo, and the lab is always open. Catch you on the next one.